Okay, so welcome back everyone. So we are going to do another series of question decoded today. As you can see the question, it is still from UI Post-UTME. The position of a particle moving along x-axis is given by. So we have the position of the particle along the x-axis is given by. So we have x equals to minus 2x minus 2t raised to the power of 3 plus 3t square plus 5. Okay, the now said find the acceleration of the particle when its velocity becomes 0. So we are looking for our acceleration. A is what to A is unknown when our v is equal to what to 0. Now, so for us to get our acceleration, you must know the equation for velocity. So okay, now let's derive the equation for velocity from here. We have our v equals to, don't forget our formula, we have when you are looking for velocity is equal to velocity is equals to total displacement over total time. But when you are looking for the instantaneous, you can simply use d what to dx over what to over dt. So you find dx over what over dt of this equation. Now how do you find it? Don't forget our normal formula, which is when you are looking for derivative of something in mathematics, you use dy what to dy over dx equals to what to nx nx raised to power n minus 1. That is, you bring your power you bring it to the left hand side of the variable. So we have power x raised to power minus 1. That's just the formula. Just memorize it like that. Power x raised to power minus 1. So we have the same thing applicable here. So the first thing is to bring your what to bring your power to the side. And what's the power here? We have 3. You are now bring it to this point. We are going to have power multiplied by minus 2. So minus 2 multiplied by 3, that will give us minus 6t. Power x raised to power minus 1. So we are still going to have power minus 1. So which is 3 minus 1. We are going to have 2. Now everything plus. So we have plus the next one, you also do it like that. So what is the derivative of this? 3t squared. Don't forget our formula, power x raised to power minus 1. So the first thing is to bring the power here again. So 2 multiplied by 3, that's also equal to 6. It should now be 6t raised to power minus 1, which is 2 minus 1, giving us 1. And we don't need to you don't need to write it there. Okay, so we have plus, what is the derivative of a constant? That's 0. So we have 0. So that is, we can assume that our velocity equals to, the equation for our velocity is equals to minus c what to 6t square plus what to plus 6t. But we've been given in the equation, in the question, that v equals to we are looking for the acceleration at v equals to 0. So at v equals to 0, let's take a look. What can we see? V equals to 0, we have minus 6t square plus what to plus 60. So you can see we can find our t from here. Yeah, now if you factorize, 0 equals to minus 6 into bracket. What do we have left? T. Okay, we have minus 6t. You can see that t is also a common factor. Minus 6t into bracket. We are left with t plus what? Okay, t minus what? To t minus 1. You can see t minus 1. So what's the next thing? You continue solving. So our minus 60 must equal to 0 and t minus 1 must also equal to 0. So minus 60 equals to 0 or t minus 1 equals to 0. So we have something like this. Now you find your t here, you can say divide both sides by 6, divide by 6. This place you collect the like times, our t equals to what? You bring it here plus what? Plus 1. So here if you divide, at the end of the day your t equals to what? T equals to 0 or t equals to plus what? Plus 1 seconds. Okay, so as you can see, we've gotten our t. The next thing is to now look for our acceleration. How do you find your acceleration? Acceleration equals velocity over time. So the first thing is to get your equation for acceleration. Now let us get it from this equation of velocity. So our acceleration equals to dv over dt, like this. So don't forget our normal formula for derivative, power x raised to power minus 1. Okay, so now moving like this, moving on, we have dv over dt. So what's our v? Our v is equals to minus 6t square plus 6t. Okay, if you continue like this, so find the derivative of this. What do you have? Power x. You bring your power here. 2 multiplied by minus 6, so we have minus 12 t raised to power minus 1. 2 minus 1, that's 1, so you don't need to put it there. Now we have plus, what's the power on this one? 1. You bring the power here, 1 times 6, we have 6 t raised to power minus 1. So we have 1 minus 1, 1 minus 1. So which is now going to be, so our a equals to minus 12t plus 6 raised to power, t raised to power 1 minus 1 is equal to 0. So we can say 6t raised to power 0, and any number raised to power 0 is equals to 1. So we have our a equals to minus 12t plus 6 multiplied by 1, that's 6. So this is the equation for our acceleration. Then you just find your acceleration. Your a will now equals to minus what? To minus 12 into bracket. We've known our t, which is either 0 or 1. So t shouldn't be what? It shouldn't be 0. So we are going to use 1 to 1 seconds. So minus 12 into 1 plus what? To plus 6. So what do we have? A equals to my what? To minus 12 plus what? To plus 6. So what's our final answer? Minus 12 plus 6. That's minus 6 meters per second squared. That's our final answer. Thank you very much.